Okay, so I did not provide notes for this, so all I did was type in how to graph a reciprocal function, and I went to my notes for today, and I just took a screenshot of the graph, and I pasted it here. I can put it wherever I want, and then I'm just going to do some notes on here. Who are we waiting to catch up? Are you ladies okay? You're good? You're good? Madeline, are you good? Is anybody still catching up here? Okay. So this function is the reciprocal function. You could also call it rational. But when I say rational functions, it includes a lot more than just 1 over x. So I'm going to specifically refer to it as the reciprocal function. Excuse me. Meaning when I go to make a table of the parent function with the key points, I'm going to take x values that I can reciprocate. So I can reciprocate negative 2, that would be negative a half. I can reciprocate negative 1, still be negative 1. I also probably pick an x like negative a half, because when I reciprocate it, it becomes negative 2 and a nice number that I could graph. Okay, so I'm picking numbers that are decent to graph and that are something I could do. If I put in 0, what happens when I reciprocate 0? It becomes undefined. Okay, so this 0 is something special. And I'm going to just write x equals 0 here for a moment and come back to it. But it does not work. That's undefined. So on the graph, x will never equal 0. We're going to come back to that in a moment. So then I'm going to also put in a half. I'm going to put in 1. I'm going to put in 2. And I'm going to reciprocate those. 2, 1, a half. Okay. So when you guys did rational functions last year and other functions last year, you learned about asymptotes. And I'm going to write the word if you can't understand what I'm saying. Asymptote. That's a P. Asymptotes. So asymptotes would be these kind of invisible lines on the graph at which your equation, your graph is getting closer and closer and closer and closer and closer to, but it never really approaches it or equals it. So x equals 0 is an asymptote. The graph cannot equal 0. It cannot have x equal 0, but it's going to get really close to it. Now, I picked negative a half to stop at, but I could have gone negative 1/9 and negative 1/10, negative 1/100th, and so on. But it's just like, I can't graph negative 1/100th. Plus, the reciprocal of that is negative 100, which won't fit on my graph anyway. So I just chose things that were easy to fit on the graph that I could graph. But this asymptote, at x equals 0, there's going to be this imaginary line, which is why I'm dashing it, and it's red. It's kind of out, but it's not really there. The graph is going to get closer and closer to it, but a graph will never, ever, ever pass through a vertical asymptote. Now, I left a space on the other side of the x equals 0, because what you might not be able to see, but we can talk about right now, is there is a y asymptote also. So in this equation, 1 over x, can you solve that to find when 1 over x equals 0? Can we solve it to find when y is 0? What will x need to be that y would equal 0, that f of x would equal 0? 1 over what number gives me 0? No, 1 over 0 is what? Undefined. And really, that's my only option to try to get a 0, is put a 0 in there. And 1 over 0 is undefined, so it can never, ever equal 0. So that is another asymptote. Y equals 0 is another asymptote. So over here on the y equals 0, I've got another asymptote. Now I'm going to graph my parent function ordered pairs. -2, -0.5, -1. And then, again, you guys probably covered this last year, but we really haven't reviewed how to graph these this year. I only need a few points, and the ones that we're going to do this chapter will look the same. They're going to look like two branches that are getting closer and closer to the asymptotes. It's hard for me to do on the computer, but I'll try my best here. Okay, so those lines are getting closer and closer to x equals 0 and y equals 0, but they're not going to cross them. So I was looking at the domain and range for this. What would be my domain? Going from left to right, what are we going to start at? If we're going from left to right, what are we going to start at? What's all the way to the left? Negative infinity. Please feel free to say it out loud. If nobody's talking, I'll just start calling on people, but it's negative infinity. Great. And then does it go all the way to positive infinity? Okay, does it go to positive infinity? Does it include every single number in between? Why are we shaking our heads no? Eden?
0.
Yeah, at x equals 0, the graph jumps. And I can't even tell you what the y value that it jumps at is because those are infinity also. So there's just this tiny little spot right at x equals 0 where it cannot equal 0. It goes all the way up to it. So I'm going to say the domain goes all the way to 0, but then it skips 0. And then it goes from there all the way to positive infinity. It just skips over that 0. And so the range, same kind of concept. It does go all the way down to negative infinity. All the way up to positive infinity, but it is skipping something. It's skipping over what? It skips over 0, right? So we've got union, 0, infinity. Okay, now you didn't actually graph any of these. You are going to have to graph some of these tonight, but we will do it with transformations. What you have done is you've taken transformations and applied it to these equations. I know that you've had some questions like that. So I'm just going to throw one out here in a different color. How about we do blue? Let's say I had something like 1 over x minus 3 plus 4. If that was my transformed equation, what would I do with that minus 3 to my ordered pairs in my table? Madeline, what would I do? Okay, I think when I said it, I might have leaned you into saying minus 3, but if it's horizontal, I'm not going to do the same operation, am I? If it's horizontal, that's okay, because I wasn't even thinking about that when I said, what do I do with the minus 3? Well, it's not going to be a minus 3, is it? It's going to be a plus 3, and that's going to apply to all of my x values. So I'm going to add 3 to all my x values. And you know why I'm doing this table right now? Because there were people on their quiz that do not know how to do transformation tables yet. Okay, and I'm just going off on a tiny little tangent here. Next chapter, we're going to have equations that look like this. We're going to have equations that look like this, and if you don't know how to do transformations, it's going to be a lot more work to learn how to do transformation tables when you're also learning how to graph a sine function with pi's. Because for this, our xy's, our x's actually go by pi. Okay, it's going to be a lot more work when we get to here, instead of let's just learn our transformation tables now. That's the only reason why I'm really teaching them by transformation tables, because I know it's coming. I can tell the future. Okay? And I also did not order, that's not even there. That goes there. Gosh, I'm not paying attention. Don't look at my graph, but just know that it counts by pies. Okay, so going back to this, if I have a translation of 3 to the right, and then what does the plus 4 on the end do? Abigail. Sorry. Up 4, so that's going to go on the y side, plus 4. Okay, if I'm going to add this in, my 3's, I'm going to have 1, 2, 2.5. Am I doing that right? Yeah. 1, 2. And then, can I add 3 to x equals 0? The answer is yes, I can. So we will add the 3 to the asymptote as well. X equals 3. And then 3.5, 4, 5. Same thing on the other side. We've got 4, so I've got 3.5, 3, 2. So can I add a number to y equals 0? Yes. Y equals 4 now. And then 6, 5, 4.5. In the graph, what's happening is now my what are they called? Asymptotes are at, put those in green, are at x equals 3 and y equals 4. And because I didn't have any stretches or shrinks on this one, it's a little bit easier to just kind of translate the whole thing. But when we start having stretches and shrinks, it's a lot harder to just move stuff, and you definitely want to be able to use a transformation table when you have stretches and shrinks. But I wanted to show you about the asymptotes because I know we hadn't gone over that. The transformations, everything's going to work the same. Okay? Any questions about this graph? How would my domain and range change for the blue graph? Or would it be the same? Phil, would it be the same, the domain? The blue one and the black one? No. What would be the domain? So because my transformation moved the asymptote to 3, that also changes my domain as the number that I'm skipping over. And then the range is the same way. It's going to change it to 4. Okay. All right, so I'm going to stop this video, and then I'm going to make a new video with all of 1.8. Okay, so if anybody needs to go back, this is a really short video to go back to see how to graph that with parent function.